element. This one, and this one, okay? For your stair. So you need a detailed drawing in both views of this little clip here, okay? So that one has three holes, this one, that one, and one in the middle. Because we put this section, this little pipe here, and welding all around, okay? So you have to select the bolts as well. So you have this view and the little rectangle on the other way, yes? Because this is a like little section, like the best plate that we are doing for the column. So you have to determine those distance. You have to determine the diameter of this little bolt here, because we have this section there. Put in the middle of that one, welding around, put the little other section over there, welding around, and keep going on that one, okay? So in the other view, is like that. So I only require this view of the handrail, okay? So you are working on the first view that we're making today, not on the front view. In the front view, you have to allocate just the little clips, okay? Not the handrail. So this one is one of the files that I sent to you. So this one works with steel and aluminum. Please be focused on steel, okay? So I think it's 50% of the file that you have to analyze, but be careful where it changes the material, okay? So if we are back to the presentation, for example, yeah, handrails. So for safety reason is why we design stairs. So one of the requirements on the safety is the handrail must be between 865 1100. Okay, so that means from here to the top. Okay, between that range. Okay. Then you can see, for example, the first example here. Plan for P. So we are inside of the range, yes? So we have the middle section. You need to follow those dimensions for this one, 560, this one, 560, then 457. You need to identify which one works for us. So this one fit, this one fit, this one fit, yes or no?
No.
Why no?
For the clip?
No. From view, the lateral view, or so like this one. So it's supposed to be here, yes, in this section.
Mm-hmm.
Doesn't match. Yes. So we cannot install this one and this one and this one because we have a C. That section cannot go inside of this C. Yes.
Mm-hmm.
So not this one because it's not for corners. So you know which one you have to use. Yes. Okay. Then you have two options here: steel, both are steel, 32 and 25. Why is that name? And schedule 10. How it looks like rectangle, like triangle,
the diameter?
diameter. Because this is a circle, yes?
Mm-hmm.
All of this section. So that means it's up to you which one you select. So there are two options now. 32 millimeters of this diameter, that one, yes? or 25. Both are correct. It's up to you which one you select. And what is the meaning of schedule? Pen, what does that mean? This is a pie. Like the thickness of the pie. Okay? So basically we have here 32. So the diameter is 32, and we have little dashed line. That little section is 10 mils, yes? And we have little section here. So it's not a massive, it's a hole in the middle. Yes? Then here we have the best plate. The same place like we have in the photo. This one here. Yes? So that one is the detail of this one here. Which one I have to select and why?
The first one,
Why the first one?
because have 3 holes like aligned with the,
This one have 3 holes as well.
yes, but now it's aligned with the,
So 2 reasons why that one is not correct. Can you read? The angle. So our angle is 43 something, yes? This one is between 0 and 14. No good one. This one is between 15 and 45. Yes? Yeah. Then you have to read this section. Obviously, you can see that this circle in the middle is not exactly in the geometric center of the plate. So this one is a little bit far from this one, okay? So that means you have a range 56 to 63. So you can create this rectangle, okay? You have this dimension, that dimension, yes? But this is a missing here. You can use chamfer 10 mils. That one is missing in this one, okay? 10 mils of chamfer, okay? So that means 10 from this point to this point, and 10 from this point to there, okay? So we use chamfer command to create that diagonal section, if you wanted to use it, okay? Otherwise, you have to calculate and make little lines, 45 degrees, one more here, but it's more complicated for you, okay? So you know the hole size of this one, 70.5. So this is the diameter of those holes, okay? So which bolts we must use? 20. Which bolts? So you know now the hole of the plate, yes? So you know, so we are calculating on the other way, yes? In all of the assignment that we are doing, we know the size of the bolts. Based on that one, we can check what the standard said, 2 mils, 3 mils, 6 mils, to determine the diameter of the hole. Now it's on the opposite way, yes? So this is less than 20. That means tolerance 2. So bolts are, we have 15.5? No. Then you have to go a little bit lower. Yeah, no higher, because you must respect the 2 mils. If you go up like 16, so it's 1.5. So you don't respect the tolerance.
So we need to use 12?
So here you have an angle, yes? Which angle is that one? I don't know, because everyone is a different angle. Yes? It's the same angle. So, which command can you use it in AutoCAD?
Align.
Align, maybe. With O? Of course. Offset. Because you have this distance, yes? And that one, yes?
Yes.
And you have, so based on this view, okay guys, don't draw here and don't draw there, just one time is enough. So you have the top, you can do offset of this line, yes? On the top line, yes? Obviously that line is the center, the dashed red line that we see here, yes? Which is the dimension. Then you can do another offset based on that one. So we are looking the detail of the plate. So in one view, it looks like the top one, yes? Like this one, yes?
Yep.
The other view, obviously need to be straight, but in this section is diagonal. So it looks like this one, this rectangle, but obviously flat. And you have to allocate again the holes. Center lines in the middle, yes? Because there are holes. So again, detail one refers to C detail one, which is this one. Which dimension I have to use it? 60, 51, or 45?
45.
45, okay. Why 45? Again,
45.
the inclination, our alpha, yes? So 45 from the center to center, which is not the same like what they said here, because this is not 45. You must respect the 45 on the bottom, okay? From center to center, okay? Not those numbers. But that one is only for the first hole with the middle one, okay? So I don't know how far it's from here to there. So you can assume you have now from the center of this hole to the edge of the plate, you have one dimension, yes? Assuming that is 23. So you can calculate that one. So use the same distance for this one, okay? To allocate the other hole. So here now we are in aluminum, which is not our material, so we don't follow that one. What else? So we have a little curve in this section here, and that one there, yes, because it's not straight. So in that one, you know the radius now. So you can use fillet command because you know the radius, yes? So you can create like straight lines, like here, like there, you have this profile there, yes? And you know the radius now. You have fillet command. Because you know the radius, with that one straight away it creates this curve. You don't need to do anything else, so you just call in the command properly, okay? And to allocate this point, remember, for safety reason, we have to provide, before the people make the first step, get the 100. So it's this section. So must be parallel to this section, okay? So you can create this line there, based on that one. So which section is this one, this line, yes? Straight one. So based on that line, until there is where your handwrite mode started, okay? Then you know the radius, then we have to keep going until the last page. Yeah. So we have a little ball here to join each section to make in one piece. So those balls in the middle have like a little hole which is welding around. But you know the diameter of that one? Not yet. So that one is, we can see the last page of this document. So we have 75, the diameter of those circles over there, okay? So how to match that one? So you have a center line. This is a point, you have a center line. And you have a center line of this one. So you get an intersection point, which is the center point of this area. Yes? So it applies for all of them, all of them. So with that information, you can figure it out how to make it. So one of the requirements on the assessment is tables, how to insert tables. So I have created a couple of tables, this one. This one is belong to your PowerPoint. This one. But we are using only this standard, okay? Don't worry about this button section in your table. So you can create tables and call into AutoCAD. If you don't remember, I already invite you to check the PowerPoint of the fly bracing last term, okay? Or you can call here table command and create the tables. Then you can set up here how many rows, how many columns do you need. You create a table, then you fill in the information over there. So how your assessment looks like at the end, without pictures, this one. Lovely, I know, so cute. So only in this view, don't put this one as well here, okay? So this one with the little balls, you respect this one, you get the correct dimensions. Then the clips must be here, okay? And views of the clip looks like this one, okay? So I think also there is a welding symbol anywhere that is 3 minutes. Look, this is the welding symbol that you must use to join the ball. So this one is given for you in your image. You don't need to take picture of this one. So I already sent this file early today.
Can you send the PDF file?
No, because we already do 90% of the assembly today. So welding symbol, 3 means all around, okay? all welding around. So you know how it looks like? So we have this one, we have this one, we have this one. You have to include the knots. You only need to design this one and the cleats and allocate those cleats over here. And that's it. I have to prepare to you for the final exam. Otherwise, you don't be ready in 2 weeks. And in the final exam, you won't have picture and any advice from me. Because I already prepared all the term. I was asking questions throughout the term about the standard. You already working to projecting things like today. So you don't pretend that I have to do everything for first day to it's like a growing. So you are now adolescent, teenagers. So you are almost out of my house.
Can you give us some example? No need the same, just something example, like for an exam.
One of the structures that we had to design looks like the same like will be in your in your exam. Slightly similar, but not the same ones that you do.
We just wanna know what we're gonna do.